All right, guys, we are going to talk a little bit about piecewise functions today. So we talked about these in class, but I'm going to give you some extra notes. We're going to just go through these step by step. Okay, so a piecewise function, we talked about this, that's made up of two or more functions each with its own domain. So again, this is really just, we take a bunch of functions and we pick which piece of that function we're going to use, and we kind of put them together on a graph. So it'll make a little more sense as we go. So first we look at this piecewise function here, and this tells us that for f of x, if x is less than -2, then we use this function. If x is greater than or equal to -2, we use this function. So basically, when we have an x, we just have to compare it. We have to say, is it less than -2? If so, we're going to use this function. If it's greater than or equal to -2, we're going to use this function right here. So let's come down here and look at f of -5. Well, this is our x, remember, because we have f of x. So we look at -5 and say, is it less than -2 or greater than or equal to -2? Well, -5 is less than -2 if you think about a number line. So we use this function x squared minus 1, and we just plug in -5 for x. So we have -5 squared minus 1, which gives us 25 minus 1, which gives 24. All right. Now if we look at this one, this is f of -2. So we look at what point are we including -2 and what point are we not. Well, this function says everything less than -2, but not equal to -2. This is just less than -2. And this says everything greater than or equal to -2. So we plug it into this one. So we use 5x plus 3, and we plug in -2 for x, which is -10 plus 3, which gives us -7. All right, and finally we have this one. So f of 7, again, this is our x, so we say, is this x less than -2 or greater than -2? Well, it's greater than -2, so we use 5x plus 3. We plug in 7. That gives us 35 plus 3, which is 38. All right, let's take a look at this one. Again, we have a piecewise function. It tells us if x is less than -4, we use this function. If x is in between -4 and 1, we use this function. And if x is greater than or equal to 1, we use this function. So here's g of x is 2, or g of 2. We look up here, well, 2 is greater than 1, so we're going to use this function, 2x cubed plus 9. So we have 2 times 2 cubed plus 9. Well, 2 cubed is 8, so 2 times 8 plus 9 gives us 16 plus 9, which gives us 25 total. So for this function, what we're saying is for this function, when x equals 2, y equals 25. That's what we're finding when we find g of x. So let's look at this function. For this function, when x equals -1, what does y equal? Well, let's come up here and say, okay, x is less than -4, we use this one. X is in between -4 and 1, we use this one. So this -1 is in between -4 and 1. So we're going to use this function, -x minus 1. So we have -1 minus 1. Well, that becomes a positive, a negative times a negative. So we have 1 minus 1, which equals 0. So what we're saying is for this function, when x equals -1, y equals 0. Okay, now so for this function, we have g of -6. So we come up here, -6 falls here. It's less than -4. So we use this function, 1/2 x plus 3, and we plug in -6, 1/2, -6 plus 3. Well, -6 times 1/2 gives us -3 plus 3, again, this one equals 0 as well. So what we're saying is for this function, when x equals -6, y equals 0. Okay, now we're going to talk about graphing piecewise functions and finding their domain and range. So remember, when we graph these, what I like to do is I like to say I'm going to graph both lines, and I'm going to keep what I want and erase what I don't want. Okay, so let's graph this first line. So this function really is two different functions, and it might be a little challenging to see this, but really this is f of x equals x, or y equals x, and f of x equals -2x plus 1, or y equals -2x plus 1. Okay, now just a review of how to graph a line. These are both in slope-intercept form, y equals mx plus b. So our b would be the intercept, and our m is the slope. Okay, so for this first line, we're going to graph y equals x. Well, that has an intercept of 0 and a slope of 1. So I can come here at 0 and 1 and 2 and 3 and so on, up 1 over 1. Y equals x is a parent function. All right, let's see. Okay, so there's that line, y equals x. And we're only going to keep this line for this domain. We're only going to keep this line for this piece of it. So that's x is less than -3. So what I'm actually going to do is I'm going to take a piece of paper. I'm going to take a piece of paper here. And I'm going to say I only want things that are less than -3. So I'm going to cover up everything that isn't less than -3. So I find x equals -3, 1, 2, 3. So this is the line that I actually want to keep, everything less than -3. So I'm going to keep that line. And then I'm just going to erase the rest of the line because I don't want this function past that. I only want my line from x equals -3 and below. And now I have to decide if I'm going to include -3. Well, I look up here and it says for all x that are less than or equal to -3. So that means I put a closed circle right here because I want to include -3 and every value for x that is less than -3. So again, my x's go this way, and think of everything that's less than -3. Okay, so let's graph the other line. Y equals -2x plus 1. So we go to our y-intercept of 1, and it has a -2 slope. So down 2 over 1, down 2 over 1, down 2 over 1. Okay, so we're going to graph this line. Okay, now we decide what part of this line do I want to keep and what part am I going to get rid of. Well, this says for everything greater than -3. So again, I take my paper, I go to -3, and I say I only want to keep the line for all of these values. See, these values of x I don't want to keep because they're less than -3. I only want values that are greater than -3. So I'm keeping these values here. So I'm going to go ahead and graph. I'm going to keep this part of my line. And then I'm going to erase the part of my line that I don't need. And then I look at this and it says only for x is greater than -3, not equal to -3. So I put an open circle right there at -3 because we don't want to include -3 in that. Okay, so you graph your function, figure out what piece you're keeping. Graph your next function, figure out what piece you're keeping. That's kind of the steps for graphing piecewise functions. So now we're going to look at this and decide our domain and range. So for domain, what I do is I say if I have my ruler and I'm going like this on my coordinate plane, am I going to touch a point on my function? Somewhere on my function. Well, if I'm right here on the coordinate plane, I'm touching a point on my function, aren't I? So here at this x, I'm touching a point on my function. My function has a point in that domain for that x. And really, since this arrow goes on forever and ever and ever and in that direction, no matter where I put my ruler, even if I went way out here, I would always be touching a point on my function because this line goes forever and ever and it will touch my ruler eventually. Okay, so I go like this and I say, okay, so forever in that direction, I'm touching a point, touching a point, touching a point, and then I get to this -3 right here. And I look, well, I'm not touching this point because this one doesn't include -3, but I am still touching a point on my function because I'm touching a point on this line. Remember, these are one function put together. So as long as I'm touching a point on one of them, it's still part of my domain. So that's part of my domain, and then I keep going and I keep going, and look, no matter where I put my ruler, I will always, always be touching a point on my function for the x. If I keep going on the x, on any x value, any x line, I'm always going to be touching a point on my function. So the domain for this one is going to be all real numbers. Now the range, we do the same thing. So let's start on the negative. I always like to start at the negative because it's the lowest value. So again, if I've got my ruler way down here, am I touching my function? Well, yeah, actually, in fact, I am. I'm touching two parts of my function, which is fine for the range. So I'm touching my function, touching my function, touching my function over and over and over. I just keep going up and up and up, and sure enough, I am still always touching at least one point on my function. Even when I keep going up here, I'm still touching this point on my function. So it's totally fine. This is still part of my range. And when I get all the way up here, which is y equals 1, 2, 3, 4, 5, 6, y equals 6, or actually that's 7, for y equals 7. Yeah, that's y equals 7 up there. So when I get all the way up to y equals 7, that is where I actually stop having any points on my function. So if I keep going up and up and up here, now at this point, this part of my ruler is not touching anything on my function. So there is not a single y value on my graph that will be higher than 7. Do you see that? So here, if y is equal to 1, there's something on my function. If y is equal to 2, there's something on my function. If y equals 3, y equals 4, all the way up to y equals 7. When I get up to y equals 7, that's where it stops. And that's where I no longer have any points on my function. So for this one, our domain is all numbers that are less than 7. So y is less than 7. Because that's where all of my y values lie. Okay, so now let's look at this one. This is another piecewise function. So let's graph the first one. The first line is y equals -3x minus 7. So this one has a y-intercept of -7. And a -3 slope. So normally we would go down 3 and over 1. Well, we can't do that because we don't have enough space. So this time we'll go up 3 and left 1. Right? So I go positive y, negative x. So that makes a negative slope still. And if you can't remember if that's a negative slope, just think about slope, dude, and make sure that this line looks like a negative slope and not a positive slope. Okay, so here's our line. Now let's figure out what part of this line we're going to keep. Well, we're going to keep everything for x is less than -1. So again, I'm going to take my paper. I'm going to find -1. There's 0, there's -1 right there. So I only want to keep the part of the line where my x's are less than -1. See, this is x is -1, this one x is -2, this one x is -3, and so on. And so all of these numbers over here are less than -1 for x. So I want to keep this part of the graph because these are the values where x is less than -1. So So I'm going to draw a really beautiful straight line there for you. All right, so we have that, and then everything past that, everything else, we don't need. We don't want that part. We only want this piece of the function from x is equal to -1 and more negative from there. So, and we also don't want to keep -1. We want, it's not equal to -1, just less than -1. So here at -1, we're going to put an open circle. Okay, so now we're going to graph the other line, which is y equals -5. Well, there's no x value for this one at all, so that means it's a horizontal line. So it's just at y equals -5. Oh, this one should be up 1. That one's right there. That's at -4. All right, so this is y equals -5. Yeah. I'll graph with this one. Okay. All right, so we graphed the line y equals -5. And now again, we need to figure out what piece we're going to use. So we go x is greater than or equal to -1. So I take my paper and I cover up everything where x is greater than or equal to -1. And that's the line I want to keep. And then I erase everything that's less than or equal to -1. All right, so we keep what we want, which is everything from x is greater than or equal to -1 and forward. So we put a closed circle here because that would be we want to include -1. All right, so let's take a look at the domain of this one. So again, we start on the x and we say, okay, this is for all x values. We're looking at our x values. So, you know, this is like, you know, x is -1, all of these ones. If I put my ruler over here, I'm always going to be touching some point on my function, right? So even if I'm way over here, this line extends forever and ever and ever. So no matter where I am over here, I always have some point on my function that has that x value. So this is part of my domain. I keep coming here and here and here. And then here when I get to -1, I'm not on the red line, but I am on the black line. So that's fine. I'm still touching at least one point on my function. So we're good. We keep going. And if I keep going forever and ever and ever in this direction, I will always have at least one point on my function that has that value. You know, even if I get to x equals 100, I will always have a point on this line right here that has the value x equals 100. So my domain again for this one is all real numbers because it goes forever and ever in both directions. Now let's take a look at our range. This one's a little tricky. So you come up here, and at this point my function does not have any y values, right? There is not a single value here that has this y value. So I come up and up and up. Well, when I get to x or to y equals -5, I am touching the function there, right? So I have values at y equals -5. At y equals -5, there are points on my function that have that value. So I do have y equals -5. But the interesting thing is in between y equals -5 and y equals -4, if you look right here, these actually don't intersect. In between -5 and -4, there are no points on our function because this one actually only goes down to -4. So in between -4 and -5, there's no values. So we can't just say, well, anything bigger than -5 because, well, -4.5 wouldn't work. That doesn't have a point on our function. But now if I go up here, everything bigger than -4, once I get above -4 for the y value, I will always have a point on my function that has that as the y value. You know, so if y equals 0, here's a point right here on my function that is y equals 0. So I just keep going up and up and up forever. So y is greater than -4. So y is less than, or y is equal to -5, or, there we go, now it's working, or y is greater than -4. So any value is bigger than negative 4 or negative 5 work for my y. All right, so hopefully these make sense. Let's go to the next page, and I'll actually make a separate video for that. So if you're still struggling, go ahead and watch that video, but if you feel like you got it, awesome, thumbs up to you.